Alright, this is a review of both study guides for Unit 5. As always, I'm just going over some of the problems that I deem like the most important ones you should look over, but all these problems on both study guides you're responsible for doing in preparation for your tests. So I'm going to just go over the ones that I'm going to star, and you should follow along with me. All right. First one that I star at number 3. Given the figure below, determine the measure of angle CDE. Things you should recognize about number 3. When you first look at all 3 of these angles that they give you are exterior angles. And once you recognize that, you should understand that on any polygon, the exterior angles add up to 360 degrees. And once you figure that out, you'll know how to write your equation. So, being that this adds up to 360 degrees, my equation for this to solve is going to be 7x minus 2 plus 4x plus 33 plus 9x minus 31 equals 360. And then also, one thing you probably wanted to do first that I didn't do is identify what angle you're trying to find. Angle CDE is this angle right here, this interior angle. So after you find x using that equation, you need to come up with your strategy of how you're going to find this angle right here. And that strategy should include understanding that these angles are all exterior. So this angle next to this exterior angle right here, this adjacent angle that we need to find, CDE, is supplementary because these two angles here and here form a linear pair. So I can just subtract from 180 once I plug back into this one right here, and I'll get my answer. That's what you should be able to identify from that. Okay, so combining like terms, I usually don't solve these for my kids, but I'm going to be nice this time. So you're going to get 20x, and then negative 2 plus 33 is 31. 31 minus 31 is going to give me 0. So should get 20x is 3 equals 360. And then 360 divided by 20. X equals 18. They did not ask me for x, so that's not my answer. They asked me for angle CDE. I need to plug back in. 9 times 18 minus 31 is going to give you 131 degrees. Once you get that, you understand to find this angle inside, you need to be doing 180 minus 131. 180 minus 131 is going to give us 49 degrees. So the measure of angle CDE is going to be 49 degrees. Next one I'm doing, number 4. Find the measure of angle STU. Like I didn't do on the first one, it's important to identify what you're looking for first. Angle STU is this interior angle right here. This one right here with a 9x minus 19 on it. So to find that angle, first we need to determine what kind of figure this is. These are all interior angles, so we need to find the sum of this polygon here first before we can write an equation. We can't write an equation without knowing what this polygon adds up to. So to find the sum, you need to use that formula that you learned at the beginning of this unit, which is n minus 2 times 180. This is going to give you the sum of the interior angles of any polygon. Count the number of sides, 1, 2, 3, 4, 5, 6. So 6 minus 2 times 180. And that sum is going to be 720 when you do the math. So all these angles in this figure add up to 720 degrees. To solve this, you need to be able to write an equation. So the equation is going to include all these angles. So you got to make sure you write everything in there. So the equation is going to be 7x plus 3 plus 128 plus 5x plus 8 plus 111 plus 9x minus 19. This is the key right here. A lot of people forget this. Plus 90 equals 720 degrees. And then we need to solve that for x and then plug back into this. And solve and combine like terms. When you combine all your x's, you'll get 21x. And then plus 321 when you combine all your numbers equals 720. Subtract 321. $3.99 and then 21x divided by 21. We're going to get x equals 19. Alright, so the value of x is 19, and then from there we need to plug back into this angle right here. Plugging back in this angle, 9 times 19 minus 19. When you do that, you get 152 degrees. So measure angle STU is 152 degrees. Moving on. Next problem I'm doing on this sheet is number 7. Alright, on this one it says if PQRS is a rectangle, PT is equal to 13x minus 9 and SQ is equal to 60. Determine the length of TR. So on this one I like to label if I can. PT is this piece of the diagonal right here. Say that's 13x minus 9. And then they say SQ, this whole diagonal this way is 60. They want the length of TR, which is this piece of the diagonal right here. You need to make sure you come up with a strategy to be able to solve this. The strategy is pretty simple too. From P to T is half of this diagonal in this rectangle, 13x minus 9. SQ is this whole diagonal. So to write an equation, you should know you can't say these two things equal to each other because they're not equal. PT is half of SQ. If that's the case, then you need to double this expression they give you for PT. So my equation would be this to solve for x. 2 times 13x minus 9 equals 60. I'm doubling PT. And I'm going to distribute 26x minus 18 equals 60. Add 18, add 18. Then you get x equals 3. When you do your math. From there, you need to plug back in. Well, not plug back in. Well, yeah, you do. I'm sorry. But you need to understand what to plug back into. PT is congruent to TR. You're looking for TR. So I can just plug back in the PT and get what TR is. So to find TR, I'm going to just use what they gave me for PT. So TR is going to be equal to 13x minus 9. And I already know what x is, so TR is going to equal 13 times 3 minus 9. You do that math, TR is going to equal 30. Alright. Next thing I'm doing is number 10. On number 10, it says given the parallelogram GHJF, FH is 16.2, GJ is 34.6, FG is 14.9. What is the perimeter of triangle KJH? Let me get a highlighter because I want to show you something on it. For this one, KJH is this triangle right here. KJH. This is what they want you to find the perimeter of. This triangular piece of this parallelogram. To do that, you need to use the measurements that they gave you. FH. FH is this full diagonal right here. That's 16.2. Then GJ is this other diagonal coming this way. They tell you that's 34.6. And then FG is this side right here. They tell you it's 14.9. Alright, that being said, some stuff needs to be split probably to help us out. Using these numbers and understanding what a parallelogram is, we can get the numbers that we need to add up the sides to get KJH, the perimeter. So you can start easy. First, if FG is 14.9, that means JH over here has to be 14.9 as well. And then FH is 16.2. That means KH has to be half of 16.2. If you divide 16.2 by 2, you'll get 8.1. 8.1 here and 8.1 on this side right here. And then the other way, 34.6 for GJ. If I split that in half, I'll get KJ. Half of that is 17.3 and then 17.3. Now, this problem is not to scale. The reason I say that, because some kids question, they were like, well, how is this shorter one longer than this FH right here? Which is a good question. It's just that we just made numbers up. They're not to scale. Just understand that you need to split these numbers in half so you can get these sides right here and then add them all together. Alright, so 17.3 plus 8.1 plus 14.9 is going to give you the perimeter of triangle KJH, which is 40.3. Number 11, next one I'm doing. The figure below represents a regular octagon-shaped pool with a deck built around it. The connections between each vertex are angle bisectors. What would be the measure in degrees of the angle marked as X? Let me find this angle right here. So to find it, you need to understand this. They call this a regular octagon. So all the sides are the same. All the angles are the same. This angle that they want me to find, X, if you look, it's on one of these connections in the pool that they call angle bisector, meaning that the angle that was created here got split in half. So X is going to be half of whatever this full angle right here is. The objective we want to do for this is, since this is a regular octagon, we want to find all these angles that this octagon creates. All of them are going to be congruent all the way around. We want to find all of them, even this one. But once we get them, this angle needs to be split in half because X is half of the angle. To find those angles, you need to use the formula that you were taught to find interior angles of a regular polygon, which is the n minus 2 times 180 divided by n. The n in this case, this is an octagon, it's going to be 8 minus 2 times 180 divided by 8. And if we do that math, we're going to get 6 times 180 and then divide by 8, excuse me. You can get 135 degrees. So what that's telling me is all these angles in here are 135 degrees. Here, 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 all the way around. I can write all of them in. 135, 135, and 135. Even this one, full one up here is 135. But we don't need that full angle. We need half of it. So you should know once you get to 135, you need to divide it by 2. 135 divided by 2 is going to be 67.5. Next one. Flip to the back. 14 and 16. 15 and 17 are just like 14 and 15. Just practice for you. I'm gonna do these two with you. You can do these two on your own if you haven't done them already, which you probably should have already done. And square G on. The coordinates G are -4, 2, and the coordinates O are 10, 4. Determine the state of the coordinates of the vertices of E and M. So they gave you the name of a square, GEOM, and then they gave you two of the coordinates, G and O. If you look, G and O are not consecutive points. The fact that they jump from G to O, it tells me that GO is a diagonal in this square. This is not a side, this is a diagonal. GO is a diagonal. They want me to find EM, the other diagonal, in this square. So on the graph down here, and we did these graphs like this on purpose too, to start getting you practice for ELC purposes, because on the ELC they won't provide you with graphs that are already numbered and stuff like that. You have to make your own graphs from a sheet of graph paper. See, I need to start practicing that. Alright, so down here you're going to kind of have to make your own X and Y axis to save space, because you got to create 4 graphs on here. You're going to have to kind of cheat your stuff over a little bit. Looking up here, my biggest number is like 10 and 4 for this one, so I got to at least go out 10 in the positive direction and 10 up just to be safe. I'm gonna cheat my graph to the left a little bit, so I'll probably come like 6 away from the side and then create my y-axis. So I'll probably create a y-axis about right here. And then come down a decent amount of the page, because I'm gonna need, I can say at least 10 up. It should be good. I didn't come all the way down, but I came down far enough. And then I'm going to cheat this section too. I'm going to give myself about a little bit of space on the bottom. Let me just make sure I save myself room to graph my stuff. Alright, so on my graph, I'm putting the 2 points that they gave me, G and O. G was at -4, 1, 2, 3, 4, up 2. O was at 10, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 1, 2, 3, 4. Alright, this is my diagonal. GO. And then from there, from there, to be able to get the, what I want to call it, to get the other points on the other diagonal, you want to find the midpoint of your diagonal right here. Like a lot of times, if you draw your line good enough, you'll be able to see it. I don't know if my line is drawn that well. I think I'm a little off because I know what the midpoint is supposed to be. But if you can't really see where the midpoint is, you can always do the formula up here to find the middle of these 2 points, which is not that hard to do. You should remember the midpoint formula is adding the x's and adding the y's and dividing by 2. If I label real quick, I could be able to find it. X1, Y1, X2, Y2. Out to the side here, I'll do midpoint. M equals, and then -4 plus 10. I'm adding my x's together, dividing by 2. And then 2 plus 4, that's my y's, dividing by 2. And I'll get my midpoint real quick. So, -4 plus 10 is 6, divided by 2 is 3. And then 2 plus 4 is 6, divided by 2 is 3. So my midpoint is going to be 3, 3. So down here on the graph, just so I'm sure I'm at the right spot, midpoint is at 3, 3, right here. Alright, you need to be able to identify that. And then from there, once you get your midpoint, what you want to do to be able to get your other 2 points, you want to get your slope from one point to the midpoint, and then the slope again. It's going to be the same on both. You just need to get slope. So from G to the midpoint, my slope, my line is going up, so I know my slope is going to be positive. My slope is up 1. I'm rising 1, and I'm going to the right. 1, 2, 3, 4, 5, 6, 7. Take it to the point, the midpoint. So my slope is 1/7. And if I do it again from the midpoint to the other point, it's going to be the same. Up 1/7. Alright. So that's my slope of my first diagonal. To find the slope of the new diagonal, up top here, you need to understand that the slope of the other diagonal, since this is a square, the slope of the other diagonal is going to be perpendicular. You need to ask yourself, what's the perpendicular slope to 1/7? And you should know you flip and change the signs. So it's going to be -7/1. That's going to be my perpendicular slope. Once you know that, then you just create that perpendicular slope from the midpoint. From the midpoint, I'm going to use -7/1 as a slope. -7 is not a rise, it's a fall. So for my midpoint, I go down 7, down 1, 2, 3, 4, 5, 6, 7, to the right 1. Once I do that, I'll land on my one of my points for my endpoint. And then what you need to do to create the other side, you kind of need to create the same slope down 7 and over 1, but you kind of got to do it backwards. So you just need to make it look the same as this one. So instead of going down 7 and over 1, I'm going to go in reverse. I'm going to kind of go to the left 1 and up 7 to create the same negative 7 over 1 slope. So I'm going to go back this direction 1, and then I'm going to go up 1, 2, 3, 4, 5, 6, 7. But even when I do that, these two slopes look the same. This is still negative 7 over 1. I just went in reverse to get it. And then up there is my other point for my diagonal. From there you can drop your diagonal in. And then you just need to read your 2 points from 0, 0. So the 2 points from 0, 0, the first one up here is going to be at 2, up 10. Second one is going to be at 4, negative 4. So these are the 2 points I'm putting up here. No matter which order, 2, 10, and 4, negative 4. I'll tell you this on your test, it's going to be multiple choice anyway, so it ain't going to matter the order. You'll figure it out. Alright, next one I'm doing, number 16. The 3 coordinates of a square PART. One is the x coordinate of point T. Alright. So in this one, they give you 3 out of the 4 coordinates on the square. Down here, we're going to do this one under here. It's a smaller graph because the biggest number is like negative 5. So we just need to make sure we go to like at least negative 6 to give ourselves some space. Now do it right under this one. Made myself a little graph down here. And I want to graph those points. They gave me point P up there, says it's at 2, 3. 2 up 3 is here. A says negative 2, negative 1. That's here. R is at 2, negative 5. 1, 2, 3, 4, 5. Then from there, they want me to find point T. If you connect your first 3 sides using the letters P to A to R, or your first 2 sides, I'm sorry, it'll kind of direct you where your third or your 4th point should be, just so you can make sure you put it in the right spot. Like once I connect P to A and A to R, I know T is going to be over here somewhere. To figure out where it is exactly, I just need to use slope again. But on this one, I only need to use slope of one of the sides right here. I try to always use my positive slope too. Like AP is a positive slope. AR would be a negative one. But you can use either one if you want. You just got to duplicate over here. But I would use A to P. And I would get a slope. My slope is from A to P is up. It's 1, 2, 3, 4. Then it's to the right. 1, 2, 3, 4. My slope is going to be 4 over 4. I want to recreate that same slope down here. And that'll tell me where my 4th point is. So it's up 1, 2, 3, 4, then to the right 1, 2, 3, 4. My 4th point is going to be right here, and that'll be point T. And I just need to tell where that point is. That point is at 1, 2, 3, 4, 5, 6, down 1, so 6, negative 1. And then all they want for this one, if you look up in the question, they just want the x coordinate. The x coordinate for t is 6. Alright. Take care of the first study guide. Going on the second study guide, showing you some more problems. This is day 2. Skipping all these up here, but I will make some mentions to you. You should recognize this problem right here from one of the problems that we did on the other study guide. It's identical. Only thing that's different, we just reworded the way the top of the question is written a little bit. It's identical to that other one, and you should know if it's identical to the other one and it's showing it to you twice, you must probably gonna see this problem on the test. So look at the refer to your first study guide, do this problem again, and remember how to do it. Alright, number 8. First one I'm doing on here. JKLM is a parallelogram. What is the value of x? So they're calling this a parallelogram, which it is. They just want to know the value of this angle x right here. Alright, this is an easy problem to do. It's an easy problem to mess up too if you don't pay attention. You gotta know about properties of a parallelogram to be able to do it. So, things you should know about a parallelogram. Since we're dealing with angles, you should know opposite angles are congruent. I know the big angle K is congruent to the big angle M. I know the big angle J is congruent to L. That should help me in finding the value of x. Alright, knowing that, looking down here, they want me to find x. Looking at this situation out here, this angle is being split by this line coming through and creating two small triangles in here. This triangle on this side, though, I see 90 degrees here and I see 35. Well, if that's the case, I can find this third angle in this triangle right here by doing 90 plus 35 and subtracting that from 180. Everybody should know that we can do that. So I'll just do 180 minus 90 minus 35 and do that math. 180 minus 90 minus 35 is going to leave me with 55 degrees. So this angle right here, the third angle in this triangle, is 55 degrees. From there, I'm pretty much almost done. All you got to do is understand that angle K is congruent to angle M. Now here, angle M is going to be 55 plus X. So to find K, I would just do 115 minus 55. 115 minus 55 is going to give me 60 degrees. Angle X is going to be 60. And that's how you do that problem. You will see something like it on the test. The numbers just going to be different. It's very easy to do. You need to make sure you know how to do it. Next one, number 9. Alright, number 9. They want us to find the measure of angle N. First thing, the best thing you do for yourself is mark the angle they want you to find. Angle N is right here. Alright. To be able to find that angle, we need to make sure that we write the correct equation based on what we're given. On this one, we're given angle K and M with expressions on it. You know the relationship, same as what I talked about on the other page. These are opposite angles. You should know that opposite angles are congruent. If that's the case, they even look congruent. And if that's the case, to find X, I need to set these equal to each other. After I set them equal to each other, to find angle N, I will plug back into either one of these. And then you need to recognize that from there, the relationship between K and N or M and N is same side interior or consecutive, meaning they add up to 180 degrees. So after I plug back into either one of these, I'm going to subtract from 180 to get what angle N is. It's a pretty simple problem to do. 8x plus 17 equals 12x minus 39. subtract 8x, subtract 8x, cancels, 17, and then you get 4x minus 39, add 39, add 39, 56 equals 4x, divide by 4. We get x equals 14. The value of x is 14. We need to plug back in though. I'm going to plug back in the 8x plus 17. 8x plus 17, so 8 times 14 plus 17. You should get 129 degrees when you do that math. And then from there to find angle N, understand that these are same side interior angles. They're consecutive, supplementary. So it's going to be 180 minus 129. And then the measure of angle N is going to be 51 degrees. Easy enough to do. Number 13. I started this one. I'm not about to do it, but I do want to mention it for you again. Number 13 is similar to the one we did on the other study guide, where they give you a parallelogram, or in this case a rhombus, and then they ask you to find a parameter of a triangle. They want you to find a parameter of a triangle JNM. To find a parameter of a triangle, you need a label like we did the last one, and then you need to split whatever numbers you need to split in half to get JN and NM, and then JM will be the same as KL. And then you just need to add all your stuff up. Only reason I want to mention this one because I think y'all gonna let something throw y'all off in this one. In this one, they put a 36 degrees in here. You're dealing with sides to find perimeter. You don't even need 36 degrees. In this problem, 36 degrees is a distractor. Do not use 36 at all. You should not be using that number at all. That's going to just there to distract you. Alright. Number 16, next one I'm doing. Given a regular polygon on a coordinate grid, which transformation will place the figure back onto itself. Now you should have seen me do one of these before. I can't remember if I've done it on video for y'all, but these are not that hard to do. So you want to go through and check to see what rotations or reflections will land this figure back onto itself, and select all that apply. As I tell my kids to do, go through and do your reflections first, because that's the easiest ones to get out of the way. So with the reflections, they got me doing a reflection over y equals x, and then a reflection over the y-axis. The y-axis one, that's the easiest one to identify first. Y-axis is right here. You're asking yourself, can this figure flip over that and land onto itself? It looks even on both sides, so yeah, if I flip this over, this should land on itself if I flip this over the y-axis. Then the other one is the y equals x reflection. Y equals x is the diagonal reflection through y equals x. And the slope for that one is up 1 over 1, up 1 over 1, up 1 over 1. I'm doing that so I can draw a diagonal line in and look at it. So when I do that, I can put a diagonal line in here, and I can look at it and determine if I can flip my image over that. I'm putting that diagonal in. That's the y equals x diagonal. Looking at that, I want to determine if I can flip this image over that diagonal and it land on itself. Looking at it, no, if you flip this image over the diagonal, it won't land on itself. The issue is this line right here is not coming through the middle of these sides like this. Like if you see how for the y-axis one, this line came directly through the middle of this side right here, so it split it evenly. So when I flip it, it'll just flip and land on itself. On this one, this side is shorter than this side on the side of the line, and this side is shorter this way. So when you reflect over, like say if I flip this point over, this point is going to end up over here way somewhere versus end up right here when I flip over. So this is going to be a no. And then the next thing you need to check is the rotations. To check and see what rotations your figure can do. Understand that a full rotation is 360 degrees. And then you just need to determine how many rotations it can do. This figure has 1, 2, 3, 4, 5, 6 sides. It's a hexagon. So it can do 6 rotations. And to figure out what all 6 of those rotations are, just divide by 6. 360 divided by 6 is 60 degrees. Every 60 degrees this figure can rotate onto itself. So just keep adding and get all your rotations. 60 plus 60, 120. 120 plus 60, 180. 180 plus 60, 240. 240 plus 60, 300. 300 plus 60, 360. These are the 6 rotations my figure can do. 1, 2, 3, 4, 5, 6. Based off that, I'm going to go and check all that apply. You just go through. Can my figure do a 160 degree rotation? You should tell yourself, no. Can my figure do a 60 degree rotation? Yes. Can my figure do a 240 degree rotation? Yes. That's how you do this problem. Alright, number 19. Given quadrilateral ABC has vertices of A for negative 5, 6, B 6, 6, C 8, negative 3, and D negative 3, 3. Determine the most specific name for the quadrilateral. So on these, a lot of times y'all don't be showing work, and I'm kind of doing number 19 and 20 to show you why you need to show work. The work that you need to show is not that hard though. You really just need to be looking at the slopes to figure out what's going on of your diagonals. So graphing this real quick. Negative 5 up 6. Six, 6. We got 8, negative 3. We got negative 3, negative 3. Alright. From there, you need to put in your diagonals, A to C, B to D. Because the diagonals that we're using to determine what the figure is. You're not using anything else. So then y'all be counting the sides. Nobody ever told you to do that. All you need is the diagonals. Now looking at this, it's more than likely either a parallelogram or a rhombus, but y'all just be guessing. The work that I'm asking you to do is not very much. To check, all you need to do is figure out the slopes. If the slopes are perpendicular, then it has to be a rhombus, because a rhombus is going to have right angles in it. And if the slopes aren't perpendicular, then it's going to be a parallelogram. It's pretty simple. Like, that's all I need you to do. But y'all not even doing that work. So I'm going to show you one more time how to do that work. We're looking at the slopes of the two diagonals. My first diagonal right here, A to C, I noticed that is going down from left to right. So this is going to be a negative slope. Negative slope. That being the case, my first move for this one to do slope is going to be down. Down however many until I line up with C. And that's down 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is negative 9. And then my run is going to be to the right until I get to C. My run is going to be 13 right here. That's negative 9 and 13. So the slope of AC, the slope is going to be negative 9 over 13. That's a 3, sorry. Got sloppy right there. Let's scratch that. I don't like how it looks. Negative 9 over 13. So for these to be a rhombus, my other slope would have to be positive 13 over 9, the opposite reciprocal. But we're just going to check real quick. That's all I'm trying to do. So slope of BD from BD is going up, left, or right, so it's a positive slope. It's going to be up. That's up 9. And then going to the right, that's going to be 9 as well. So the slope of BD is going to be 9 over 9, which reduces down to 1. So the slope of BD is not perpendicular to AC. If that's the case, then this isn't a rhombus. This has to be a parallelogram. I want to show you the difference now. Alright. Going to the next one. Number 20. Asking us to do the same thing. Tell which quadrilateral this is. Graph it real quick. Negative 5, up 7, 2, 6. This is M, A, then 3, negative 1, T, then negative 4, 0, and H. Similar to our last one, it looks like it could be a rhombus, looks like it could be a parallelogram. To determine that, we're going to put our diagonals in, and we're going to find slope, and we're going to compare. I'm going to do the slope from M to T first. Determine that, and then I'm going to do it from A to H. So N to T, once again, this line is going down, left to right. Down is going to be negative, that's negative 1, 2, 3, 4, 5, 6, 7, 8. And then to the right, it's going to be positive 8, so negative 8 over 8. So my slope from M to T is going to be negative 8 over 8, which is negative 1. Perpendicular slope to that will be positive 1. So let's see. A to H is going up, and then over to the right this direction. It's going up 6, going to the right 1, 2, 3, 4, 5, 6. So my slope from A to H is going to be 6 over 6, which is positive 1. These two slopes are perpendicular to each other. That means this is a rhombus. This is the difference between the two. The last one was a parallelogram, this one was a rhombus. You need to be able to just look at the slopes and determine which one it is. And then after that, number 21 is asking us about 20. It says, refer to the previous problem. Which of these is true about the diagonals of the quadrilateral? Please check. Place a check under the correct response. Diagonals bisect each other. Yeah, well, we know that about any parallelogram. Diagonals always bisect each other. That's a yes. Are the diagonals perpendicular? We just literally proved that right here. The diagonals are perpendicular because this is a rhombus. And then after that, are the diagonals congruent? The diagonals are not congruent. You can even see that from the measurements we took. This one was -8 and 8. This one was 6 and 6. No, diagonals in the rhombus won't be congruent. And then the diagonals bisect the opposite angles. It is a rhombus, so the diagonals, they're perpendicular and they're going to bisect these opposite angles here. That is the property of a rhombus. This is a yes. Alright, 23, next one I'm doing. Don't skip number 22, I'm just not doing it. This one I double starred this one because this is one of the ones I think we did in a set of notes before. And this problem, you're going to see it again, I promise you. You need to know how to do it before you get to the test. Charles wrote a proof based on the given information about quadrilateral ABCD. So what was given on this one, they told you it's parallelogram ABCD. So they're calling this a parallelogram. That being said, they want to prove that angle ADC is congruent to angle CBA. Alright. So we just need to put this proof in order. This proof is kind of already all filled out. We just need to put it in the correct order. Things that I'm going to mark on here first though. They call this a parallelogram, so I'm going to go ahead and say that opposite sides are congruent. So AD is congruent to BC, and then AB is congruent to CD, like that. Alright. Then from there, put my proof in order. Well, I kind of just helped y'all out with the first line. Since they call this a parallelogram, we should know that these opposite sides are congruent. So my first choice would be D. Right here, AD is congruent to BC, AB is congruent to DC, given. Because they did give me that. They told me it's a parallelogram, so I automatically know opposite sides are congruent. Then from there, then you want to know what step 2 of this proof will be. Reading through, the next thing that makes the most sense is going to be A. Draw a diagonal AC through any 2 points that exist one line. So it just tells me to put a diagonal in on this proof. On this diagram. So I'm going to drop a diagonal in for AC. Just so I can see it. Alright. And that's going to be my next step, A. After that, putting that diagonal in, that kind of helps me see what they're trying to show me. Now I have 2 congruent triangles in here on this parallelogram. That being said, they share this side right here, AC. So this side is congruent to itself. AC is congruent to CA by the reflexive property. That would be B. And then after that, I've kind of proven that these triangles are congruent by side-side-side congruency, E. And then the last thing I could prove, what they asked me to prove, which was angle ADC is congruent to angle CBA. They are congruent because corresponding parts on congruent triangles are congruent. We proved the triangles to be congruent right here by side-side-side. So now we can talk about corresponding parts, which is C. Alright. Look this one over, man. Figure out how to put these in the right order. You might see the same exact thing tomorrow. Complete the following proof by filling in each statement, remembering to mark all given information on the diagram. Alright. Number 24, another proof. On this one, give some multiple choice out to the side. We just got to fill in the missing pieces here. Alright. First thing they tell me, ABCD is a parallelogram. So once again, we can mark those opposite sides congruent here and here, here and here. And then going through, I'm going to need to put my choices over here in statement, one is missing, but it says given. What my given information was, ABCD was a parallelogram. That's C. Line 2 says AB is congruent to DC. How do I know AB is congruent to DC? Well, line 1, they told me ABCD is a parallelogram. That's how I was able to mark these as congruent. If that's the case, in a parallelogram, opposite sides are congruent. Alright, so that's going to be B. Then line 3, statement is missing, but it says in a parallelogram, diagonals bisect each other. So in this one it says the diagonals bisect each other. So we need to show that. That the diagonals bisect each other. This diagonal AC is bisecting BD, so it's going to split them in half. So you're going to have this be congruent to this, and then you're going to have AE be congruent to CE here. Alright. If that's the case, I can name a pair of the diagonals if they name them. Yeah, they said AE is congruent to CE. So that's A. And then on line 4, it says DE is congruent to EB. And why? For the same reason as line 3. Because DE and BE or EB were the other set of diagonals that got split. So that's going to be D. In a parallelogram, diagonals bisect each other. And then, by process of elimination, all you're left with is E. The triangles are congruent by side congruency. Alright, so that's the end of the study guide review. One of the longer ones, but I went over a lot of problems, probably around 15 to 16. I guarantee there's probably around 15 to 16 problems on your test. Every one that I touched on here, you're going to see some version of it on your test. So you need to make sure you look over those problems, finish the ones you haven't finished, and then be prepared to take your test.